Carbonate hydrolysis in calcareous soil, as you know this equation. The carbonate converted to hydrogen carbonate, calcium, and OH. Consequently, the hydrolysis of calcium carbonate will increase pH because there is OH released, so will increase the soil pH to 8.3. However, sodium carbonate increases soil pH to 10 because of sodium carbonate more soluble than calcium carbonate. For this reason, the soil contains 15% of exchangeable sodium are highly alkaline. Highly alkaline mean high pH. The relationship between the amount of annual rainfall and the soil pH. In the desert area, no rainfall, lower rate of all chemical process, consequently you will find less leaching rate of basic cation forming alkaline soil. So in desert or arid condition, usually found alkaline soil. In rainy area where high precipitation and high rainfall, increase the rate of all chemical processes, increases leaching rate of basic cations and carbonate, consequently formation of acid soil is occur. Okay, why pH is important on soil to be measured? Because the soil pH affects the solubility of mineral, as we discussed previously. The high acidic soil, pH less than 7, high acidic is less than 4.5, contain high concentration of aluminum and manganese to a degree that may be toxic to the plant. So in acid condition, usually you found these two elements in toxic concentration. Most elements dissolve in acid soil more than alkaline or neutral soil. The soil pH affects plant growth by affecting microbes in the soil, usually bacteria active on neutral pH, while fungus are more active in acid pH. Nitrogen fixing bacteria, as I will explain in next lecture, in leguminous plant become inactive in acid solution. So nitrogen fixing bacteria, rhizobium, is active on neutral condition or alkaline condition, while it is inactive in acid condition. So the pH dominate most process related to agriculture productivity in soil. Most of agriculture crop grow well in the soil pH equal to 6.5 neutral condition, near to neutral condition. Plants that grow in alkaline soil often have poor growth, so it's not preferable, not prefer to have a very high or strong pH on agriculture. Alkaline soils reduce the solubility of all micronutrients except molybdenum, but zinc, copper, most of these micronutrients precipitate on alkaline in the form of carbonate or oxide. Phosphate also in alkaline soil is not available, or in alkaline soil, or usually add phosphorus in the form of phosphoric acid, because you need alkaline soil to decrease the pH, while in acid soil you want usually to increase the pH. In Europe, usually, because their soil is acidic, need usually to increase the soil pH. They need lime, while here on the Middle East and in arid condition, we usually need to decrease the pH. So usually European countries send us a peat moss organic residues to help us improve our soil condition, and I think we need also to export a lime for them to help them increasing their soil pH. Alkaline soil reduces the solubility of all micronutrients. Phosphate also is not available on plant for plant uptake due to its precipitation on the soil solution by calcium or absorption on calcium carbonate surface. What's the meaning of buffering capacity? May I ask you the meaning of soil buffering capacity? The soil buffering capacity is the ability of the soil to resist the change in the pH value. Most soil can resist the change in pH when adding acid or alkaline material. The buffering capacity of the soil works to remove hydrogen ion from the added acid or neutralize the hydroxyl ion of added base. The process of buffering occurs through cation exchange capacity. I told you reverse acidity and active acidity. Reverse exchanged on the soil particle. Hydrogen exchanged in the soil particle called reverse. The buffering capacity of the soil increase with cation exchange capacity increase, because the reverse acidity increases. Here an example how the buffering capacity work. If you have a colloidal particle and H is exchanged on the soil colloidal particle, so this is a reserve acidity. If you put ammonium hydroxide on this aqueous solution, aqueous means water solution, so the ammonia will be exchanged, ammonium ion will be exchanged, and water will be released to the soil solution. Consequently, the ammonium effect to increase the soil pH will be disappear. However, here if you add lime to acid soil, so the calcium will be gained or exchanged here, and calcium carbonate will reduce as a gas, while the H2O will be found on aqueous solution. Consequently, the pH will be constant, and the change will be negligible or not significant change in soil pH, because ammonia and lime were neutralized to either exchangeable ammonium or calcium ion plus water. The buffering action of the soil controls the concentration of dissolved element in the soil solution by cation exchange capacity. Yeah. Soil buffering capacity increases by increasing the soil CEC. Yes, of course. Consequently, the clay soil has a higher buffering capacity than sandy soil, and organic soil have a higher buffering capacity than other soils. Clay soil is rich in clay content, especially montamorlanite and vermiculite. and organic matter have a high buffering capacity, unlike sandy soil, due to high cation exchange capacity, which which absorb hydrogen ion and have a reserve acidity, a higher reserve acidity of a clay and organic matter. The high cation exchange capacity, the high reserve acidity, and consequently high buffering capacity. What buffering capacity is the resist of soil to change the soil pH.